This short video is about multivariate linear model or n-factor linear model. A two-factor linear model can be defined as equation number 1, y equals alpha plus beta 1 x1 plus beta 2 x2. Okay. Accordingly, for the n-factor linear model, we can define as equation number 2. For this video, we have 3 tasks. Task number 1, run a simple two-factor linear model. Task number 2, run a linear model with a dummy variable. Task number 3, actually for some cases, we can run a linear model for a non-linear model. For example, equation number 3, you see y equals alpha plus beta 1 x plus beta 2 x squared. So this is not a linear model. However, we can treat it as a linear model. C15-6. Otherwise, you can choose one of the following 2 methods to download the data. For method 2, you can download the text file. For method 3, you can download the Excel file. As I mentioned before, we have 3 ways to get the data. So this is method 1. Simply type .c15. Input is 6. So this is our dataset. We simply copy paste to Excel. We launch Excel and paste our data there. Okay. And as the first step, we have to separate into different columns. We click Data, Text to Column. Choose the first one. Next, choose Space. You see, all the data set is cut into 3 different parts. Okay, so this is our data. Okay. And salary in thousand, this is Y, and experience is first independent variable x1, and test score is s2. So this is a two-factor linear model. x1 experience, test score is x2. To run a two-factor linear model is the same thing as run single-factor linear model. So we click Data, Data Analysis, then we choose Regression. For the Y range, we enter Y column. For X, instead input 1 column, we have 2. Check the label. And I want output the same spreadsheet. Then click OK. So these are our results. Okay. So if you watch my first 2 videos about single-factor linear model, you should know how to interpret these 3 parts. For example, alpha is 3.17 based on the t statistics. It's the same thing as a 0. x1, beta 1 is 1.4, beta 2 is and it's a statistic different from 0 because t is higher than t critical value. And it is true for the beta 2. The value of beta 2 is 0.25 based on the t or p-value. Beta 2 is also statistically different from 0. Please pause this video to download the second dataset. If you're currently taking my course, just type .c15-16. Otherwise, use one of the methods to get the data. For the second multivariate linear regression, so let's get the data set. We use the second method. We copy and paste to browser. So this is our second data set. We're going to copy paste to Excel. We paste it here. As before, we separate them into different data column. We click data, text to column. Again, choose the first one. And it's automatically choose tab or space. We simply finish. Okay. For this data set, and same as before, we have experience. So this is x1 and test score x2, and then we have the degree. So this is s3. So actually this is dummy. So this is y. Okay, so this is a dummy variable. Okay, and we can simply copy these two to here. Okay, to here. Okay, so this is again, so this is x1, so this is x2, and then we have x3. And suppose we choose no as 0 and yes as 1. So if this one equals no, we end 0, otherwise we end 1. So we expect a 0. Okay, then we copy and paste. You see, the first one is no, second one, so it's 0, second one yes, we have 1. Okay, so all these 4 columns are numerical. So we treat this one, this as y, x1, x2, x3. So we call it dummy. So this is dummy variable. Okay, same thing as before. We can run it. Okay, so we click data regression. We click data regression and data analysis regression. So this is y, and now x, we have 3 columns, x1, x2, and x3. Same as before. Okay, now suppose I want to choose a new spreadsheet. Just click here, then click run. Okay. Again, running we can easily add a dummy variable. So this is dummy. Okay, this is so this is alpha, beta 1, beta 2, and beta 3. So based on this dummy variable, we know it is not statistically significant. So actually it means whether you have degree or not, will not have any impact on your salary. Please pause your video to get the last data set. Again, we have 3 methods to get our data set. Method 1, we are going to generate ourselves. Then we just continue watching. So we are going to generate using Excel to generate. Alternatively, you can use method 2, method 3 to download either Excel file, a CSV file, or Excel file. For the third case, we can use, for some cases, we can use linear regression to get a result for non-linear model. So this is a typical example. Y equals 2 times 3 times x squared plus some error term. Obviously, this is not a linear model because the power of the independent variable of x is 2. It is not 1. So let's generate our own x and y column. For the x, we start from -10, -9, and we copy and paste. Okay. And to add some variation to y, we can generate some a set of random numbers. The easiest way to add random number is RAND. Okay, we hit enter. So this will generate random number between 0 and 1. However, one of the disadvantages to generate random number here is, suppose we have some operation, we type 9 here, our value will change automatically. The second disadvantage is all the students will generate all kinds of different set of the random numbers. So in order to generate the same set of random number, it is a good idea to use random number generation. Click Data, Data Analysis, Random Number Generation. Click OK. Because we are going to have one column, so this is 1. In total, we have 22 random number or observation. Assume we generate from uniform. Okay, the random seed. For individual student exercise, you don't have to enter any random seeds. You just fix them. You just generate a set of random number. However, in order to generate the same set of random number, we choose the same random seed. Suppose we choose, everybody choose 1, 2, 3, 4, 5 from uniform between 0 and 1, then we'll get the exact same result. Okay, the output range, we know we want to put the first random number here. Then we click OK. Now let's calculate y. So y equals, so we know 2 plus 3 times x squared. So this is, okay, so this is x column and this is y column. Okay, and so let's draw the graph. Okay, so we highlight x, hit Control key, then this is y. Again, we highlight x column, hit Control and hold the Control key, then we highlight y column. We click Insert, we click Recommended. So this is our graph. So obviously this is not a linear model. Okay, linear model. Okay. However, we can transfer into a linear model. So let's use y. So let's copy y here. Okay, so this is y. We just let's put it here. Y column here. Okay, y column. So let's call this one z. Okay, so what is the z value? Z value is x squared. So z value is x squared. So literally this is y equals alpha plus beta times z. So actually, if we choose z equals x squared, then this becomes a linear model. Okay, so let's run the linear regression. Okay, so we click Data Analysis, then we click Regression, then we enter, so this is still the y column. Okay, so here is our z column. So actually as x squared labels, so let's choose output range here. Okay, so you see this intercept is 2, intercept is 2, the slope is 3, exactly as our designed 2 and 3 here. So this is mean we can also use, for some cases, we can use linear model in place of nonlinear model. Now let's look at the graph. Okay, we highlight Z column first, hold the Control key, then Y. Click Insert, click Recommended Chart. Obviously, this is a straight line. After watching this video, you can try following hands-on exercise. Challenging task number 1. Run a capital assets pricing model. Recall, a single-factor linear model has the following format: y equal alpha plus beta x. So actually, beta, the slope in finance, is called market risk. For example, if we want to calculate IBM's market risk, then we have the following single-factor linear model. On the left-hand side is called excess market return. It is y. On the right-hand side is market minus risk-free rate. So this is called market risk premium. So left-hand side is individual stocks risk premium. On the right-hand side, x is market risk premium. Download the latest 5 years monthly data for IBM and for SP 500 from Yahoo Finance. Then run regression number 2. Challenging task number 2. Run a farmer-friendly 3-factor model for IBM and compare it with the result based on equation number 2. So this is a 3-factor model. Left-hand side is also, we have the same excess value for IBM. On the right-hand side, the first factor same as before. The second and third factors are small minus big portfolio and high minus no portfolio. For the second and the third factor, you can download from Professor French data library.